Next project is a sun tracking system. So sun tracking system basically, as the name suggests, you have sun, which is a source of light. We have a photovoltaic cell. So nowadays non-renewable energy sources are very important. Now generally what we have, these solar panels are fixed on the top of the building, and during morning you receive a hot water, in the afternoon it's not working, and due to today's lifestyle we generally go for wash in afternoon only. And other thing is, it can generate electricity with the solar panels. So to improve the efficiency of this solar panel capturing, we are designing this sun tracking system. Now this sun tracking system has two LDRs connected. So its arrangement is one LDR here, one LDR here. There is an obstacle plate. Now there is only one possibility that both LDR receives the same intensity is when they are perpendicular to the sun. Because if you tilt it more, then this LDR will receive more light than this. If you tilt it on other side, then this LDR will receive more light. So only one possible where they are same is the center location, and this is how it adjusted to the perpendicular to the sun. Now when this plate is perpendicular to the sun, this plate is facing sun, and this plate is your panel. So when your sun moves like this, your panel also moves like this. On the next day morning again it goes back, resets and moves like this, and it will happen. So this becomes one axis sun tracking system. Now the two axis system. Why we require two axis system? Because your sun not only goes from east to west, it also travels from north to south, and that is called Uttarayan and Dakshinayana. Every 6 months it shifts its location slightly, but over the 6 months this shifting is quite appreciable. So it will have basically two axis system. One axis will rotate it east west, and the second axis will rotate it north south. So it's like azimuth angle and elevation angle. And again the same mechanism is used. Feedback. One LDR will be facing perpendicular to the sun always, and other LDR pair will be something like this. One on this side, one on this side. So this is the plate, two LDRs. This is the plate, two LDRs. Okay. So this is how the two axis sun tracking system works. Where in the block diagram we can see we will have an MUC, ADC, will have two LDRs or four LDRs depending upon single axis or two axis. We have a servo, because servo has limitation of 180 degree, and earth also has same limitation because your sun can see through 180 degrees only. So servo is the best preferred because you can move it to a precise control of 1 degree, and then depending upon two axis we will have one servo or two servos. So this is servo 1. Its arrangement is servo 1 will be mounted on the top of the shaft of servo 2. This is servo 1, and servo 1 shaft will be connected to a panel. And this is how a sun tracking system will work. So application of this project is obviously sun tracking, but it can be also used as satellite tracker and any other, because satellite, if you receive maximum signal from the dish antenna, you have to see in the location of where the dish antenna is. So all the geostationary satellite follows the sun's path. The same system can be used as a satellite tracker also, and any other applications where the tracking is required.